We have been studying our solar system for more than thousands of years, but it wasn't until the last few centuries that scientists began to understand how it all works. The era of robotic exploration, which involves sending unmanned spacecraft beyond Earth to act as our eyes and ears, is only around 55 years old. Currently, a fleet of space robots is exploring locations ranging from the Sun to even planets far away orbiting distant stars. Scientists have known since the dawn of space exploration that spacecraft might collect scientifically useful data on the different planets of the solar system, moons, and smaller entities. In the late 1950s, both the United States and the Soviet Union attempted to launch robotic expeditions to the Moon. Pioneer 0 to 3, the first three of the U.S. Pioneer spacecraft launched in 1958, failed to return data about the Moon. Pioneer 4, launched in the year 1959, the fifth mission, was the first spacecraft of the U.S. to escape Earth's gravitational influence. It went by the Moon twice as fast as intended but provided important data. Luna 1, 2, and 3 were three Soviet missions that probed the Moon's neighborhood in 1959, proving that it had no discernible magnetic field and returning the first photos of the Moon's far side. The first spacecraft to fly by the Moon was Luna 1, 2 months ahead of Pioneer 4. Luna 2 was the first spacecraft to collide with another astronomical object after landing forcefully on the lunar surface. Lunokhod and Lunar spacecraft soft landed on the Moon in the 1960s and early 1970s, with some collecting soil samples and returning them to Earth. The United States was the first nation to launch a spacecraft to another planet's neighborhood in the 1960s. Mariner 2 passed by Venus in December in the year 1962 and Mariner 4 passed by Mars in July 1965. The Soviet Venera explorations of Venus' atmosphere and surface from the middle of 1960 to the middle of 1980 and the American Viking landings on Mars in 1976 were among the key achievements of planetary missions in the ensuing decades. Since then, just as the Soviet Union did up until its disintegration in 1991, the United States has maintained a highly active program of solar system exploration. Japan sent probes to Venus, the Moon, Mars, and Halley's Comet, and it returned samples from asteroids Yugu and Itokawa. Giotto, Europe's first autonomous solar system mission, also passed above Halley's Comet. After the beginning of the 21st century, it sent missions to Venus, Moon, and Mars and Rosetta Philae, an orbiter lander, to a comet. The Chandrayaan-1 in 2008, by India, and 2 Change in 2007 and 2010 were launched by China to orbit the Moon. Yutu, a small rover, was placed on the Moon by China's Change 3 mission in 2013, and Change 4 performed the first landing on the Moon's far side in the year 2019. Mars Orbiter mission, by India, entered the orbit over Mars in 2014. China put the Zhurong rover and the Tianwen-1 lander on Mars in 2021, and the same year an orbiter from the UAE named Hope entered the Mars orbit. NASA's Dawn mission launched in 2007 and spent 2011 and 2012 orbiting around the massive asteroid Vesta, before beginning its 2015 orbit around Ceres, which is a dwarf planet. Scientists may now gather information on the Earth itself from a new perspective thanks to space stations, satellites, and space shuttles. Earth observation from space has significantly added to basic knowledge in addition to practical uses. The ability to precisely determine the shape of the Earth, its rotational motion and internal structure, and periodic motions of the oceans such as tides, have been made possible by the use of satellites to perform various geodetic measurements. This is an early and ongoing example. Observations and measurements from orbit have also been useful in fields as diverse as seismology, oceanography, and archaeology. Thanks for watching. Hope you enjoyed and learnt something. Subscribe to Explified for more such content. See you in the next one.